Welcome to this digital healthcare workshop. Today we're going to be looking at how maths and computer science can be used in a healthcare context and how technology is also used in medicine to help treat people and improve their quality of life. This workshop is all around medical devices and how we can use healthcare in technology. First, let's get started with what are medical devices. A medical device is something that is made to help people stay healthy or get better, and it's used by doctors or nurses or by patients themselves. We've learnt what a medical device is, so let's go through some of them and see what you think are medical devices. Is an X-ray machine a medical device? What do you think? Yes or no? X-ray is a medical device because we use it to look inside people's bodies and it can help tell us things about them that will help inform diagnosis. So anything that helps doctors or nurses do their job, as we've just seen. What about an ENT diagnostic set? Should anyone know what ENT means? Or take a guess? ENT is ears, nose and throat. So we can use this device to look in people's ears, nose and throats and see if there's anything wrong with them. So this is also a medical device. What about a stethoscope? Again, yes, this is a medical device. Doctors use it to hear people's heartbeats, and this can be help in the diagnosis to see if they've got heart murmurs or things like that. So yeah, medical device. What about a tongue depressor? Does anyone know what these are used for? The name might give it away. Do you think this is a medical device? So a tongue depressor is used to hold down the tongue so people can look at the back of your throat. And again, this is a medical device. You might just think this looks exactly like a lollipop stick, and it does because they are very similar. But this is specifically used in a medical context for doctors to analyse and treat a patient. So again, this is a medical device. What about thread? Is this a medical device? Again, thread might be used in a medical context for sewing up people during surgery. This is definitely a medical device. And the thing with these things like thread or tongue depressors, which might not necessarily seem like medical devices, they are, but they have to be specifically approved for medical device. So if I took a lollipop stick and used it as a tongue depressor, that's not a medical device technically because it's not been medically approved. They have to go through regulations to make sure they are safe for use. For example, we don't want to get any splinters when using a wooden stick. And specific threads, I can't just take the same thread you get from the shop to sew with and sew up someone. It has to be safe for use on and in the body. And finally, what do we think about the NHS COVID app? You might remember using this. Is this a medical device? Again, yes it is, because we used it to monitor our own health, to get information from the NHS and to keep us safe during COVID. So this again was a way of using a medical device, and it's slightly different because it's technology and it's on our phone and it's health at home. But again, this is a medical device. So we have many different examples of medical devices here. And we're trying to transition from traditional medical devices to smart healthcare devices that we can monitor at home to make things easier, more accessible for people. Medical sensors and software such as mobile apps make it easier without leaving the home, and you can get information from and to your doctor through things like apps as well. So it makes it a lot easier for us to keep on top of our health. So our task for today is to create an app-based medical device that monitors stress at home. So this workshop will have a specific flow. We want to create a medical device that is all around an app, but to do this we need to start from the beginning, and this is kind of like The Apprentice, if you know that. So we want to start at the very beginning. What's the concept of our idea? Who's it for? Because a key thing about our work is looking and talking to people with the lived experience of what we're trying to solve. So we need to figure out what is the healthcare problem we're solving first, who will we targeting, and what do they need? What is something important they need so that whatever we create, they are at the core of this, because we want to create something that is worthwhile and something that the users are gonna, or the patients will use. We need to then look at the design, how it'll work, what are the features, is it user friendly, how are you going to collect data, and then once you've collected data, what are you going to do with it, how are you going to analyze it, how are you going to present the data, what are you going to do with the data, and then once we've done that, we need to create the app. how are we going to present the app? What are we going to put on it? We need to make the app functional and show the stress scores and the stress data that we have created and analysed. The final part of this is marketing your app. You want people to actually use it. So this is an additional task where we can also look at how digital skills in art and science can be used in other ways as well. So you need to look at your graphic design. You need to think about usability. Is your poster visually appealing? How are you going to make sure people find out about your app, find out about it for their specific healthcare, and make them want to use it? So you need to really market your product well. So this is a well-rounded project you're going to be working on today. There's 3 different projects we're going to be working on. We've got one around heart health, one around diabetes, and a project around mental health. So quickly just going to introduce a little bit about these healthcare topics so you've got a bit of information, and if you have time you can go away and research these a little bit more so you can see and learn about these healthcare problems. So firstly we'll start with diabetes. Does anyone know anything about diabetes at all? So diabetes is a condition where your blood sugar or glucose levels are too high. Glucose gives us energy and we get this from carbohydrates. You may have heard this before. For example, if you eat a banana, there are 17 grams of carbs within a banana, and these are broken down in our body, in our digestive system, into glucose. And then the glucose enters our bloodstream and we use this for energy. A hormone called insulin, again you may have heard of insulin, helps glucose enter our cells and fuel our bodies. So we get energy from glucose, we need it, but it needs to get into our cells for us to make it usable and for us to make the most of it. And insulin is the important thing here that helps glucose enter our cells. Now there are 2 types of diabetes, and you may be familiar with this. Type 1 diabetes is when your body doesn't make any insulin. There's a reason or a problem why your body doesn't make insulin, and this means that glucose cannot enter our cells, so we can't gain energy from glucose in that way. And type 2 diabetes is when your body can't make enough insulin, or the insulin just isn't working properly, and this can be known as insulin resistance. So there are 2 different types, and you may have these for different reasons, but it's all around either insulin not being made in your body, or your body not making enough, or it not working properly. And one big thing is that stress can make insulin not work properly and cause insulin resistance. So if you get super stressed, your insulin resistance can go up and you may have really high blood sugar levels. And this is then a problem for people with diabetes. You may be more familiar with heart health, as this is a bit more general, and there's many different things that can affect your heart, such as a heart attack, stroke, heart disease, or blood clots. And there's many different causes of this as well, which is why we need to try and keep ourselves healthy. But there's many hereditary or genetic reasons as well why we may have an unhealthy heart. Poor eating habits, high blood pressure, stress, smoking, obesity, diabetes, these are all things that affect our heart. But once again, one of the key factors here is stress. And finally, mental health. Mental health is just as important as physical health, and it can present as physical symptoms in our bodies too. And so it's really important that we are looking after ourselves and making sure we treat mental health as importantly as physical health. And one important factor that affects mental health is stress again. And for example, you may have experienced this during upcoming exams, for example. You may feel really stressed or anxious, and you can feel this within your body that makes you feel not very well. This is an example of stress presenting in your body. So as we've mentioned, stress is a really big part of our body and our health, and it can cause a number of other things such as seizures. It can impact your immune system, stomach issues, breathing problems, skin issues, can help you stop sleeping. And so if we can control stress and monitor our stress at home, we can take those steps to improving our healthcare. Stress triggers mental and physical changes in our body, and these can be detected by different technologies. One of the biggest things is heart rate. So if we can detect stress by increased heart rate, breathing rate, brain signals, and body temperature. So if we can measure these things, we can monitor and detect stress and see how it changes over time. Stress monitoring technologies use both hardware and software. So the hardware is something like a wearable device, like a smartwatch, and it senses the body's signals, it can detect your heart rate, and then it uses software to process the data. So things in the cloud or an app on your phone to process the data. And heart rate is one of the most common body signals we can use to collect by smartwatches to detect stress. And the key thing here is heart rate variability. This is what your smartwatch is detecting, and this is how we calculate stress. It's the heart rate variability, and this means the small changes in time between each heartbeat, and this is a strong indicator of stress. So here's an example of heart rate variability. On the screen here, we've got an example of heartbeat data, where you've got these strong peaks here representing each heartbeat, and between them and the black arrows shows the time in milliseconds between each heartbeat. So between the first 1 and 2 is 859 milliseconds, between the middle 2 is 793 milliseconds, and the last 2 is 726 milliseconds. So between each of these heartbeats, the time between them has varied slightly, so it's going from 859 all the way down to 726, and this is normal and expected and healthy. We want there to be some variability. This is what a good sign of our hearts being healthy and being able to react to different scenarios and being in a good healthy state. If the time between the heartbeats is actually the same or very similar, this is an indicator of high stress. So by measuring the variability between the heartbeats, this tells us whether a person is experiencing stress or not. So this is what we're going to be looking at today. So to actually measure stress, we use an equation called RMSSD, and this is the root mean squared of the sum of the differences. And you don't need to remember this, but this is what we're using, and we're going to go through it now. So the first step is to measure the difference between the heartbeats and write these down. So we call these the RR intervals because the peak, as you can see on the graph at the top, the really strong peak, that's called the R peak, and you can look and research about what the P, Q, R, S and T mean. These are all different parts of the heart beating, and they were randomly assigned these letters, so you can have a little research if you've got time on what these other peaks show. But we're just looking at the difference between the R peaks. So we call these the RR intervals. So the first thing to do is find the RR intervals between these peaks. Step 2 is looking at the difference between each pair of consecutive RR intervals, so the time gaps between each heartbeat. The third step is just to square these differences. Squaring this means multiplying each difference by itself, and this just gets rid of any minuses we might have here. Step 4 is find the average or the mean of the squared differences. So we add them all up and then we divide it by the sum of the number of the differences. And step 5, we take the square root, and this undoes this square that we did earlier. And then the final value we get there is the RMSSD value, or a stress score value, which tells you your variability in heart rate. And we use this then as an indicator of whether this person is stressed or not. So let's go through an example here. Step 1. The RR intervals are, on this figure here, 828, 845, 754 and 742. So these are the intervals between these peaks here. Step 2, we need to find the difference. So what we do is we subtract one from the other. So the first one is 828 and the second one is 845. So what's the answer here? You can calculate it now and tell me the answer. So this is minus 17. So now we need to do the second one, take away the third one, which is 845 minus 754, and the answer is 91. And now the final one, 754 minus 742, and the answer is 12. So we found the differences. So on to step 3. We need to square the differences now. So we need to do minus 17 squared, 289. We need to do 91 squared, which is 8,281. And finally, we need to do 12 squared, which is 144. So we found the square of the differences. Now we need to find the average of these squares in step 4. So we've got to do 289 plus 8,281 plus 144 divided by 3, which is 2,904. Now the final step, we need to take the square root of this. So the square root of 2,904 is 54. So our RMSSD value is 54. This is our stress score value. The RMSSD value, or the stress score value, only means something if it's referencing to the person that you are taking it from. Because my stress levels and your stress levels are very different, and my baseline stress and your baseline stress are very different. So that number doesn't mean anything unless we've got something to refer it back to. And there are average stress scores, or RMSSD scores, for males and females. And this graph here shows an example of this. And our stress scores decrease with age. So if we had 54 was our calculated value, if you look at this graph, who do you think this value belongs to? I'll give you a few seconds to have a look at the graph and see. If it was 54 on the y-axis and the age is on the x-axis, how old do you think the person is, and are they a male or a female? From this graph, we would potentially say that this is approximately a 30-year-old male who has an RMSSD score of 54. In the blue line here, because the female line is the red line, and that score doesn't actually go up to 54, does it? So from this graph, as an average, we could suggest that a person with an RMSSD score of 54 is a 30-year-old male. But if you have a smartwatch and things like this, it measures your personal stress scores, and the more data it collects from you, the more personalised and unique that data becomes. So the score it reflects and the stress levels it detects will be personalised to you. So that's why, and the use of smartwatches can be great for monitoring health at home, because it is unique and personalised data. Now we will actually do an example of this by hand. To measure our heartbeat, you can use something called an ECG, and this is a machine here that's on the left hand side in the screen. And these are things where you can clip things around your wrists or different parts of your body. Sometimes in the hospital they might put them on your chest, and this detects your heartbeat, and it will print off a long strip of graph paper, and it will have your heartbeat on, like is shown in this image here. So we can actually calculate the stress score, or RMSSD, from this strip of paper, like we did just do as an example. You can see there's strong R peaks here. So on this paper, on the graph paper, each small box is 0.04 seconds or 40 milliseconds, and each large square is 0.2 seconds or 200 milliseconds. So what you need to do is you need to count the squares between each R peak and calculate how many seconds that is, and that's your R to R interval. And you should do this for a series of R peaks, so you've got 3 or 4 R peaks. Find the intervals between them, and that is step 1 in the RMSSD equation, and then you just need to do what we just did on the previous slide, do the calculation, and for that person and the example you have, see what the RMSSD value is for them. And remember to keep this value safe, because this is the value we're going to be using in the apps later. So what do the stress level numbers actually mean? So for example, when your smartwatch detects your stress levels, it might score this on a level of 0 to 100 and use a scale such as 0 to 25 being a resting state or just no stress, 26 to 50 being low stress, 51 to 75 being medium stress, or 76 to 100 being high stress. But this becomes more personalised to you and your body and your natural stress levels the more data your smartwatch collects. So for example, 76 might be high stress for me, but actually 50 might be high stress for you, depending on your different bodies and our different experiences and our different health conditions as well. So this is why smartwatches can be useful, but we need something to refer it to. When you calculated the RMSSD value earlier, it took how long? Maybe 10, 15, 20 minutes just to calculate one value, but our smartwatches do this automatically. So now we can use some code, mathematical models and algorithms to analyse some data and see how quickly we can calculate RMSSD and see what other information it can give us. The data we're going to use for this code is from someone who's going through different levels of stress. So hopefully we'll be able to see a change in stress over time and figure out what is personal to this person. What are their threshold values for no stress? What's their threshold for low stress? And what is their threshold for high stress? So we can see how their RMSSD value at a certain point reflects on this and whether this value is then high, low or no stress. So this is the important thing we want to find out today, is the RMSSD value and the threshold values, because we're going to use these values in our app later on. And we can also produce graphs, hopefully that look something like in the top corner here, where we can plot the data and we can also color code it to make it easier to interpret on the eyes. So you can have a go at the coding now and see how you get on. It's finally time to make the app. So we want to make an app that shows the stress score and the threshold values we just calculated. We want to display this really clearly on the home screen so it's easy for the users to see and to monitor their stress throughout the day. So we should make it look nice and easy and clear. So we should want it to show green if there's no stress, orange if there's low stress, and red if there's high stress. I think that's a nice, easy color-coded system. And your apps will look something like this. So for example, if there's high stress, it'll show something like this. If there's medium stress, it'll show orange, and if there's no stress, it'll show green. And everyone is working on a similar app, but they're all different healthcare applications. So you can modify these apps however you like to include information about either diabetes, mental health, or heart health. And all the apps will, it's important that they all show the stress score on the home screen. That's the important thing here. Not only do we need to make it look good, but you actually need to code the app, and we're going to do this using blocks. Some of you may be familiar with blocks, or if not, there'll be a tutorial here and your teacher can show you how to do this. But we need to think about it logically. With the values that we had and the thresholds we've got, we need to make sure that it shows the right score and the right colour. So for example, for high stress, we want it to say if the RMSSD score is less than whatever value you just calculated, we want it to turn red. So think about the value, what was the threshold that you calculated for high stress? We want it to be less than that, because a low RMSD value, remember, means high stress. And if it's a high value, that means low stress. So for no stress in green, if the RMSSD value is greater than the value you calculated as the threshold, turn this green. But if it's in between, if it's low stress, if the RMSSD score is greater than the high stress score, but lower than the no stress score, we want it to turn it orange. So in this one's got a little added extra step because we're doing greater than and less than. It's got two conditional values here. So this is the logic behind how we think about this, but this is also the logic that coding uses. So remember this when you're doing the coding task. Use the logic function on Thunkable, and remember to make sure your less than, your greater thans, and your ands are all correct in that order. There's information sheets, and please ask for any help. Digital skills can also be used in the world of art, and in our case, this can be used for marketing our product. Market a product, you want to make sure that it looks good, that you think about graphic design skills, that is visually appealing. How do you use these skills and digital skills to make sure that you are selling your app in the right way and making sure that users want to use your app? So this final task is all around marketing. You want to make sure you explain your product well. How are you going to sell it to someone? What's the purpose of your product? Does someone know that this is specifically for heart health, diabetes, or mental health? Is the target audience clear? Who is it for and why? And why should they use your product? What is the benefit for them? And does your poster look appealing? Are the colours nice or do they clash? Can you read the text that you've got on there? Have you got any images? Is it accessible? And here's some examples of images from the NHS or different apps that you can see just for some inspiration.